Hey everyone, just wanted to do a really quick video going over some of the wave stuff. Hopefully everyone did the POGL since it's based off of that. Alright, so first thing that you should have gotten from the POGL was that waves transfer energy. This is an extremely big thing because waves only transfer energy, nothing else. Now the two forms that waves come in are mechanical waves, which are physical waves and require a medium, while electromagnetic waves don't require medium. The only thing that's an electromagnetic wave is light and all of its forms. A good indicator of whether or not something's mechanical or electromagnetic is look on the second page of the reference table where you find the electromagnetic spectrum. If it's not on that list, then it's not an electromagnetic wave. All right. The two shapes that mechanical waves come in are transverse waves. This is where particles move perpendicular to the wave motion. If you look at this diagram, the wave is clearly moving to the right and these particles are moving up and down perpendicular to that motion. Transverse, perpendicular, even has a perpendicular symbol on that T. This is easy to see and it's going to be the one that you see the most because it kind of looks like a sine or cosine curve. The second one is the longitudinal wave. This is where the particles will move parallel to the wave motion. This one's a little hard to see. It's not really going to the right or left, but you can clearly tell that the wave's going to be going horizontally. And you can see these particles also move horizontally. Another thing that these longitudinal waves are called are sometimes compression waves because they get areas of high compressions and areas of low compressions. These are the parts of the transverse waves that you learned about. The crest is the highest point. The trough, that's how it's pronounced, trough, is the lowest point. Wavelength is from one point to the next same point. So from crest to crest, and then trough to trough. And then amplitude is the height of a crest. Now on this diagram right here, there are one wave going from here over to here. Over to this point will be 1.5 waves. I don't really know what this extra part is, but one full wave is from this point all the way to this point. That is one complete wave. Now, some things that we can use to calculate for waves are things like frequency and period. Frequency, represented by the scripted F, is the number of waves per second, how many waves you see every second, and it's measured in hertz. Period, which is represented by a capital T, is the number of seconds per wave, and it's measured in seconds. So period is just a fancy time. There's three equations. The first two are not on the reference table. It's frequency equals waves per second. Period is number of seconds per wave. Again, straight from their definitions. This is the only one that is on the reference table. T equals 1 over frequency. Once you find frequency, you've immediately found period because they are inverses of each other. All right, so we're going to have you work on these questions, and then we'll go over it in a second. All right, so for this first one, what we want to do to find the frequency is waves over seconds, and we get that the frequency is going to be 3 hertz. The next question, to find the period, I can either do 3 seconds over 9 waves to get 0.33 hertz, or what I could have done was I could have said that period is 1 over the frequency, which is 1 over 3, or just realized this is not hertz, 0.3 seconds, 0.33 seconds. All right. Next one, pretty much the same thing. So to find the frequency, again, we want the seconds on the bottom. So 300 seconds goes down here. Waves goes up top. I know my handwriting is perfect. And I believe this one will end up being I can do it in my head, 0.3 hertz. And then same thing to find the period. The time goes on top. 90 hertz, 90 waves goes on bottom. And we get 3.33 seconds. All right, here's the next one. All right, I'm not even gonna do the work on this one. 60 waves, 60 seconds. Just divide them, we get 1 for both. So the frequency is 1 hertz, the period is 1 second. All right. So with number 4, so they give us the frequency this time. So this time we're actually using the third equation, and they want the period. So period is 1 over the frequency, which is 1 over 340, or in decimal, that would be 0.003-ish, rounded. Now the next question says how many waves would pass by in 3 seconds? So I can do a few things. What I would want to do is I'd want to use the definition for frequency being waves per second. Now I know that my frequency is 340 hertz. I don't know how many waves that is, but I know it's going to occur in 3 seconds. So cross multiply, and I get that the number of waves is going to be 1020 waves. The next question says that it's basically the opposite. We want the time it takes for 15 waves. So I could pretty much do the same thing. Waves per second. My frequency is 340. I'm talking about 15 waves. And I'm trying to figure out the time. This time what I recommend is when you do this, you have to cross multiply. 340x equals 15. So the time will end up being 0.044. Some of you may have been smart enough to realize that you just take the to find C, you could have also just taken the period, the time for one wave, and multiply by 15 to find the total time. And same thing for B, you could have found the frequency. Just realize that you take the frequency, the number of waves per 1 second, times it by 3 to find the waves for 3 seconds. All right, try question 5. All right, for question 5, it's a pretty standard 1-1 method. So period is 1 over the frequency. They have an inverse relationship. My period, my frequency is doubled, and according to this, my period has to be halved. So the answer would be A, halved. Try this one. All right. For question for part A, the period of a wave. So according to this, I want to look for the time for one complete wave, which if I look, one full wave ends right here, which is 0.2 seconds. Now sometimes they may give you extra parts of the wave. I only want to make sure that when I'm looking for period, I stop after one full wave. So my period is going to be 0.2 seconds. The frequency will be 1 over that 0.2 seconds, which, when you do the math, is 5 hertz. And then for part C, they want the amplitude of the wave. So amplitude is to the highest point, which in this case is 0.04 meters. And that's pretty much it. All right, have a good day.